Hi all, welcome to Engineers Think Box. This is Sharu. In this video, we'll solve a problem on overlap add method. So the question here is, find the output y of n of a filter whose impulse response is h of n 1, 1, 1 and the input signal value is x of n using overlap add method. So to begin with, firstly we will be calculating the values of L, M and N, which will be the first and foremost step. So what is this L? This L is the total number of terms present in the sequence of x of n. So x of n contains 10 terms here. So the value of L will be 10. Next, coming to the M, M is nothing but the total number of terms in the impulse response sequence. So here it is 3, so M is equal to 3. Using this L and M, we are going to calculate the value of N. The formula is L plus M minus 1. The value of L is 10, the value of M is 3, plus 3 is minus 1. So if we are going to compute it, we will receive N value as 12. So now what does this N represents is, the question is given like you have to find the output Y of N of a filter. Okay, so your ultimate aim is to compute y of n. This y of n length is 12. That is, the output will be having 12 terms. Okay, so this is what L, M and means. Okay, so this is the step 1. Coming to the step 2, here this x of n is considered to be a long sequence. Okay, so what I'm going to do is I'm going to section these long sequence to small terms. So that is why this overlap add method and overlap save method are also called as sectioned convolution, where you will be sectioning the input signal and you will be solving. So here I'm going to section the terms, that is divide the terms to make the computation easier. So here I'm going to take first 3 terms. Okay, first 3 terms, and I have placed the first 3 terms here. Okay, to this 3 terms, I will be appending these zeros. I will be appending the zeros such that I will you will be calculating the values of zeros using this formula m minus 1. The value of m is 3, 3 minus 1 is 2. So for all the things, the thing will be like you will be taking 3 values from x of n and you will be appending 2 values as per this formula, that is m minus 1. So each value will be having 5 terms. Okay. So x1 of n will be having 5 terms. Initially I have taken 3 minus 1 0 and I have appended 2 zeros since it is m minus 1. Next I will be considering this 3 terms 1, 3, 2. So this 1, 3, 2 will be placed here. With that I will append 2 zeros, that is m minus 1. Next 0, 1, 2 is the next 3 terms. I have taken the 0, 1, 2 here and I have appended 2 zeros here. And finally, see here, here only 1 is present, but I need 3. I need 3 terms, right? So for which I will be appending 2 zeros with 1 here. Yes, and again append 2 zeros as part of m minus 1 zeros. Clear? So now, similarly, this procedure will also be done for h of n. So h of n is also appended with 2 zeros. So now, the x of n value is x of n is sectioned into that is 1 x of n is now sectioned into 4 x of n's. Now it will be easier for the computation. Please ensure that the values of x1 of n, x2 of n, x3 of n, x4 of n, h of n, everything should be of equal size. So that is why we are going to append as many zeros. Okay, so here the size is 5. 1, 2, 3, 4, 5, and here is also 5, here is also 5, here is also 5, here is also 5. In order to make it 5 only, we have added this 2 zeros here. Okay, so this is the step 2. So in the next step, our ultimate aim is to find the output y of n. Okay, so now we have sectioned these x of n, that is input signal, to 4 sections. Now I will also get y of n as 4 sections, and finally I will be using a trick to end up with final y of n. That is where overlap add method comes into picture. So first y1 of n, y2 of n, we have to calculate this for y of n's, for which you will be in order to calculate y1 of n, you will be doing x1 of n circular convolution with h of n. For y2 of n, x2 of n circular convolution with h of n. y3 of n, for that you will be x3 of n circular convolution with h of n. And finally, in order to get y4 of n, you will be circular convoluting x4 of n with h of n. So now let's see how to circular convolute these stuffs. So first we know the x of n value is 3 minus 1 0 0 0. That is, I have taken it from here, 3 minus 1 0 0 0, and h of n value is 1 comma 1 comma 1 comma 0 0. So these are the values I have taken here. Now I am going to do circular convolution, for which you will be forming a matrix where you will be entering the values like this. So here x1 of n value is 3 minus 1 0 0 0. 3 minus 1 0 0 0. In the next column you will be starting from this point, 3 minus 1 0 0 0. In the next column, in this point, 3 minus 1 0 0 0. And here in this column you will be starting here, 3 minus 1 0 0 0. And finally you will start here, 3 minus 1 0 0 0. You could see a pattern, right? So this is what you will be, this is how you will be entering this x of n value. Now you will be multiplying with this h of n. H of n is 1 1 1 0 0. Now you will be doing normal matrix multiplication only. That is 3 ones are 3, 0 into 0 0, plus 0 into 1 0, plus 0 into 0 0, plus minus 1 into 0 is 0. Now here minus 1 into 1 is minus 1, plus 3 into 1 is 3, plus 0 into 1 is 0, plus 0 into 0 is 0, plus 0 into 0 is 0. Now coming to the third row, 0 into 1 is 0, minus 1 into 1 is minus 1, 3 into 1 is 3 plus 3, and 0 into 0 and 0 into 0 will be 0. Now coming to the fourth row, 0 into 1 is 0, 0 into 1 is 0 again, minus 1 into 1 is minus 1, 3 into 0 is 0, 0 into 0 is 0. Now coming to the last term, 0 into 1 is 0, 0 into 1 is 0 again, 0 into 1 is 0 again, minus 1 into 0 is 0. So 3 into 0 is 0. This is just a normal matrix multiplication where you will multiply each and every row with this column. Okay. Now if you are going to solve this, it will be like 3. Here 3 minus 1 is 2. Here again minus 1 plus 3 is 2. Here only minus 1 is there, minus 1. Here it is 0. So now we have got the y1 of n value. Similarly, we will be solving for y2 of n, y3 of n and y4 of n. Now coming to y2 of n, we will be circular convoluting x2 of n and h of n. The x2 of n value is 1 3 2 0 0. You will be substituting like in this format, like 1 3 2 0 0. Next it will start here 1 3 2 0 0, 1 3 2 0 0, 1 3 2 0 0, 1 3 2 0 0. Okay, I hope you can understand this pattern. With this you will be multiplying the h of n. Again normal matrix multiplication comes into picture. 1 into 1 is 1, 0 into 1 is 0, 0 into 1 is 0, plus 2 into 0 is 0, 3 into 0 is 0. Coming to the second row, 3 into 1 is 3, 1 into 1 is 1, 0 into 1 is 0, 0 into 0 is 0 again, 2 into 0 is 0. Coming to the third row, 2 ones are 2, plus 3 into 1 is 3, plus 1 into 1 is 1, plus 0 into 0 is 0, plus 0 into 0 is 0. Here 0 into 1 is 0, plus 2 into 1 is 2, plus 3 into 1 is 3, plus 1 into 0 is 0, 0 into 0 is 0. And finally in this row, 0 into 1 is 0, 0 into 1 is 0 again, 2 into 1 is 2, 3 into 0 is 0 and 1 into 0 is 0. Now if I'm going to solve this, I'll get like here 1 and 3 plus 1 is 4, 2 plus 3 plus 1 is 6, 2 plus 3 is 5 and here 2 again. So this is the value of y2 of n now. Now I'm going to solve for y3 of n. So this is y3 of n value is the x3 of n value, that is 0, 1, 2, 0, 0. I will be putting it in this matrix like I did for previous both steps. 0, 1, 2, 0, 0, 0, 1, 2, 0, 0, 0, 1, 2, 0, 0, 0, 1, 2, 0, 0, 0, 1, 2, 0, 0. Okay. And again I'll multiply with h of n. If I'm going to multiply it, again a normal matrix multiplication. 0 into 1 is 0, 0 into 1 is 0, 0 into 1 is 0 again, 2 into 0 is 0, 1 into 0 is 0. 1 into 1 is 1, plus 0 into 1 is 0, 0 into 1 is 0, 0 into 0 is 0, 2 into 0 is 0. Coming to this place, 2 into 1 is 2, plus 1 into 1 is 1, plus 0 into 1 is 0, 0 into 0 is 0, 0 into 0 is 0. Here 0 into 1 is 0, 2 into 1 is 1, plus 1 into 1 is 1, 0 into 0 is 0, and finally 0 into 0 is 0. Finally 0 into 1 is 0, 0 into 1 is 0, 2 into 1 is 2, 1 into 0 is 0 and 0 into 0 is 0. Now if I solve this, the first term will be 0, the second term will be 1, third term will be 2 plus 1 is equal to 3, again 2 plus 1 is equal to 3, and here it will be 2. So this is y3 of n. Now finally I am going to calculate for y4 of n. So here the x4 of n is 1, 0, 0, 0, 0. So I will be putting it in the matrix in such a way that 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. So this is how you have to put it in the matrix, and followed by that you will be multiplying the h of n 1, 1, 1, 0, 0. So anything, this ultimately forms the identity matrix. So anything multiplied with identity matrix will be the same answer. So here it will be like 1, 1, 1, 0, 0. So this is y4 of n. You can also multiply and cross check it. Okay. So now I have got the answers for y1 of n, y2 of n, y3 of n and y4 of n in the previous steps. So I have taken all the answers for y1 of n, y2 of n, y3 of n and y4 of n, and I have written here. Now what we have to do is we will be writing all the answers in each rows. That is, first we will be writing 3, 2, 2, minus 1, 0. 3, 2, 2, minus 1, 0. Remember we have in the first step, in the very first step, we have appended 2 zeros here, that is m minus 1 zeros. So what we have to do here is you will be overlapping for 2 terms, that is m minus 1 zeros we have appended. Okay, so 3 minus 1 is equal to 2. So while you are going to place the next, that is y2 of n, you will be overlapping with that with 2 terms. So here it will be like 14652. That is 14652. Next, again 2 terms I will overlap. That is here, this 2 terms. And I will place the y3 of n values. That is 0, 1, 3, 3, 2. 0, 1, 3, 3, 2. And finally, I will be overlapping this 3, 2, that is 2 terms. That is 3, 2, 1, 1, 1, 0, 0. I will be placing y4 of n value. So it's clear, right? What I'm doing, I'm going to place y1 of n and y1 of n, y2 of n, y3 of n and y4 of n by overlapping 2 digits. Since the value of m is 3, I'm going to overlap m minus 1 terms. So that is what I have did overlap. So this is overlap. Add. Now we are going to add the terms. So here This 3 will come as such, this 2 will also come as such, this 2 will also come as such. This minus 1 and plus 1 if we add, we will get 0. This 0 and 4 if we add, we will get 0. This 6 will come as such. This 5 and 0 if we add, we will get 5. This 2 and 1 if we add, we will get 3. This 3 will come as such. This 3 and 1 if we add, we will get 4. This 2 and 1 if we add, we will get 3. This 1 will come as such, this 0 will come as such, and this 0 will come as such. So this is what overlap add method is. We will be overlapping for m minus 1 terms and we will be adding the terms. Okay. So initially we have calculated the value of n as 12. Yes, do you remember it? Initially we have calculated the values as 12. So what we are going to do is, I am going to take 12 values, the first 12 values. That is 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. This is the answer. These 2 zeros I am going to leave. So first 12 terms I am going to consider. Okay. So now this is the y of n. Now in order to cross check whether your answers are correct, I will be using linear convolution method. This is easy way to check whether if your answers are correct or wrong. The thing is, you will be writing x of n this side and h of n in this side. This will be x of n and this will be h of n. Okay. Now I will be multiplying these both. Okay. 3 ones are 3. 1 into minus 1, minus 1. 1 into 0, 0. 1 into 1, 1. 1 into 3, 3. 1 into 2, 2. 1 into 0, 0. 1 into 1, 1. 1 into 2, 2. And finally 1 into 1, 1. For each terms I will be multiplying it. Since both are 1 again, so the same values will be coming here. Say for example, here it is 2 now. You will be instead of 1, if it is 2, it will be like 3 into 2, 6, minus 1 into 2, like that it will be going on. So since it is 1 here, I am leaving it. Okay. Just for making you understand, I am saying this. So you will be placing your x of n here, you will be placing your h of n here, and you will be multiplying the stuffs. After that, you will be drawing these lines diagonally. You could see, right? First I will be taking one term, next I will be taking 2 terms diagonally, next I will be taking 3 terms diagonally, after which I will be taking 3 terms diagonally continuously, and finally I will be taking 2 terms and 1. This structure of lines will be drawn. Okay. Now after drawing this line, I hope you can understand how to draw the lines. Okay. So now this first line, this first part, it consists of 3. So I am writing 3 here as such. This part consists of 3 and minus 1. I am going to add both the terms. 3 minus 1 is 3 plus minus 1. That is 3 minus 1 is 2. Here it is 3 minus 1, 0. I am going to add these 3 terms. So 3 plus minus 1 plus 0 is 2. And here it is minus 1 plus 0 plus 1. This both will get cancelled. So it will be like 0. Here 0 plus 1 plus 3. That is 4. Here it is, this is not multiplication, this is addition. Please ensure this. 1 plus 3 plus 2 is 6 here. 3 plus 2 plus 0 is 5. 2 plus 0 plus 1 is 3. 0 plus 1 plus 2 is 3. 1 plus 2 plus 1 is 4. And 2 plus 1 is 3. And finally 1. This one. So now check this and this. Both will be same. Okay. So 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. This is how you can check whether you have ended up with the correct answer. So I'd like to recollect the steps. First, you will be calculating the value for L, M and N. L will be the length of x of n. M will be the length of h of n. N is nothing but the length of the output sequence y of n. Then you will be sectioning the x of n and you will be appending m minus 1 zeros. And finally, you will be multiplying all the x1 of n, that is, you will be circular convoluting all the x of n's with h of n, and you will end up with y1 of n, y2 of n, y3 of n, y4 of n. Now we will be overlapping and place the all the y of n's, and such that m minus overlapping m minus 1 terms, and you will be placing the y of n's, and you will be adding the terms. After that, you will be considering only 12 terms from the set. So this will be the answer, for which you will be shortcut to find whether you have calculated properly is x of n will be placed here, h of n will be placed here. You will be multiplying both the terms. You will be ending up like this. Then you will draw lines in such a way that is shown in this slide, and you will be adding for each terms 3, 3 minus 1, 3 minus 1 plus 0, and so on. So ensure that these both values are same. Only then the answers are correct. So this is all about overlap add method.